Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So today I would like to continue our lecture for chapter 4. As you know, we already done our 3 chapter for amplifier, operation amplifier, and chapter 3 active filter. Now I will teach you chapter 4 voltage regulators. This topic actually, the topic name is voltage regulators, but it's actually introduce you how to get the constant DC voltage from AC until you have a constant DC voltage. So it actually is a DC power supply chapter. Okay, so what is a voltage regulator? It's provide a constant DC output voltage that is essentially independent of the input voltage, output load current, and temperature. So there are many type of voltage regulator. Okay, so voltage regulator is one part of the power supply. Okay, which is the last part of the power supply. Okay, from your transformer, from AC input transformer, bridge rectifier, we will see it. Okay, so it depends how many voltage you want for DC. Okay, so this is the objective. So objective first to describe the basic concept of DC power supply and voltage regulation. As I mentioned just now, it's a base DC power supply. And then second, to discuss the principle of series, shunt, and switching voltage regulation. So this is the type of the voltage regulator. And lastly, we will see the IC voltage regulator and some of the application. So this one is also one type of the AC voltage regulator, okay, in IC type. Okay. So this is the DC power supply of block diagram. Okay, starting from 120 volt RMS to transformer, rectifier, filter, and IC regulator here, and to the load. So if you can see, our input is AC, okay, alternating current. Okay, and then we will rectify, filter, and regulate until we have the constant DC power supply. Okay, so these are the items that we have in this DC power supply block diagram. Okay, starting from transformer, okay, direct rectifier, or you can use a bridge rectifier. Okay, capacitor filter, and regulator. Okay, regulator is IC regulator. Okay, so you have to know this item and also the function. Okay, so transformer we have to in this case we want to step down the AC voltage 120 to a smaller voltage level. Okay, and DC rectifier is to provide a half or full wave rectified voltage, which is to have a efficient, we want to use the full wave rectified voltage. Okay, for diode we will use 4 diode to construct the full wave rectifier, or we can call it as a bridge rectifier. And capacitor filter. Okay, so in this chapter we will have 2 level, okay, of capacitor. One we have a first level is we only have 1 capacitor, and another level we will add another capacitor and also resistor. Okay, so what is the function? To reduce the ripple content in the pulsating DC and try to make it smoother. Okay, it's not smooth yet, but smoother than the rectified voltage. And then lastly is the IC regulator. So this one will make your DC voltage smooth and almost ripple free. Okay, it must have some noise, okay, or ripple, okay, because it said here is almost ripple free. And then to keep the DC voltage constant through input DC voltage varies under certain condition. Keep the output voltage constant through the load connected to the output DC voltage changes. Okay, let's say you want to have a 5 volt output, so you have to use the IC regulator that can give you 5 volt DC output. Okay, so this is the item and the function. So this is a famous question for the final and test. Okay, so next we'll go one by one later. So this is the overall system. Okay, the overall DC power supply is a device or system that supply electrical or other types of energy to an output load or group of load. Okay, so you have to know what is happen to the I call this waveform after it pass through each stage of DC power supply. Okay, okay. For example, for this is supply for the system. Okay, AC. So this is, let's say this is 120 volt RMS. Okay, and then after transformer, you step down the transformer, and the voltage amplitude is smaller than input. And after you rectify, all the voltage, all the negative voltage become positive voltage. Okay, so this is the output for the full wave rectifier. And then after you put the signal through the filter, your signal will be like this. Okay, still have ripple but almost DC. And after the IC regulator, the waveform now become the smooth or DC voltage. Okay, constant. You can have a 5 volt or negative 5 volt. Okay, depends on your IC regulator. Okay, so this is what consists in the power supply. So it's actually have a transformer here, transformer, rectifier, filter, and voltage regulator. So this is how it's explained how the AC become a fixed DC. Okay, so you can read. So I will explain more on the regulation. So the regulation is usually obtained from an IC voltage regulator unit or chip. Okay, it's a small chip which takes a DC voltage and provide a somewhat lower DC voltage, which remain the same even if the input DC voltage varies or the output load connected to the DC voltage changes. Okay, so this IC voltage regulator may help to maintain the desired DC voltage. Okay, so the AC voltage typically 240 RMS is connected to a transformer. So this is the power supply in your home, which step down that AC voltage to a level for the desired DC output. Okay, so step down using transformer, and then the diode rectifier then provide a full wave rectified voltage and convert AC to DC voltage. That is initially filter a simple capacitor filter produce a DC voltage. Okay, now we want to positive all the negative voltage. Okay, and then the regulated circuit can use this DC input to provide a DC voltage. Okay, not only has much less ripple voltage but also remain the same DC. Anyway, if you want less, if let's say you want 5 volts, so you will get 5 volts. Okay. And then this voltage regulation is usually obtained using one of a number of popular voltage regulator IC unit. Okay, so we will go through to the each part. Okay, so this is transformer. Okay, transformer is an electrical device that transfer energy from one circuit to another by magnetic coupling with no moving parts. So this is the electrical diagram for the transformer. So we will have a primary and secondary part. Primary is where the supply comes and the load is connected to the secondary part. So they are operated by a magnetically coupled. Okay. So there are two types of transformer, whether you want to stepping up or stepping down, but usually in distribution we will use the stepping down AC voltage or current transformer. Okay. So transformer consists of two coils. The primary winding is directly connected to the voltage source and secondary winding is connected to the load. Okay. So this is one type of transformer. So this is the pole mounted distributed transformer with center tap. Okay. So this is the other type. Okay. So this one is a transformer in the electrical substation somewhere in Australia. Okay, this is the electrical transformer diagram. Okay, you have the primary and secondary. So usually the primary will be labeled with 1, N1, I1, V1, and secondary winding will be labeled with N2, V2, I2. Okay, so this is the part of the transformer. So we will have this iron core. Okay, this is iron core. Okay, and the winding. Okay, primary winding and the secondary winding. So N is a winding, turn number of winding. Okay, the iron core of a transformer is made up of sheet of rolled iron, and this iron is treated such that it has high magnetic conducting quality throughout the length of the core. Permeability is the ability of a material to allow the magnetic flux, okay, to flow through it. Okay, so there is no contacting of current. So they are operating by magnetically conducting. Okay, so if you transfer that diagram into a electrical symbol, the transformer will become like this. Okay, with a winding. Okay, so you have V1, I1, okay, and V2, I2, and load. Okay, you also will have the N1 and N2. N1 and N2 is the number of turns for primary winding and secondary winding respectively. And V1 and V2 is the voltage across the primary winding and secondary winding respectively. Okay, so the formula for transformer is very simple. Okay, so this one, before you want to go to the simple formula, you have to know how the magnetic flux, okay, work in the winding. Okay, so according to Faraday's law, the voltage across the primary winding and secondary winding are V1 is equal to N1 d flux over dt. Okay, and also same to the V2. So or you can change V1 is equal to 4.44 flux M F N1 or V2 4.44 flux M F N2. So 4.44 is a fixed constant for this formula. Okay, so you have the flux, maximum flux, okay, Vm, and also F, the supply frequency, and one is primary winding, primary turn, and N2 is the secondary turn. Okay, so this is the uh, simple formula. Okay, V2 over V1 is equal to N2 over N1 is equal to N turn ratio. Okay, you also have the power conservation. The energy supplied to the primary must be equal to energy absorbed by the secondary. Okay, so you will also have this. Okay, so you also have this. Okay, this is the formula. Okay, you also can write the formula as is equal to B2, sorry, N2 over N1. Okay, so if you can see V2 and V and N, the 2 is on the top, and for I on the for I, the 1 is on the top. Okay, so don't change the value of 2 and 1. Okay, so when N is equal to 1, we generally call the transformer an isolation transformer. And then Usually the n is more than 1 or n is less than 1. Okay, so for step up, n is greater than 1 lah. Okay, so for n is less than 1, the transformer is step down. Okay, so for step down, usually in the DC power supply, okay, in this chapter, you will have n is less than 1. Okay, so the rating of transformer is usually specified as V1 over V2. Okay, so you can get this from the transformer. Okay, so let's say this one is to 2400 to 120 volts. So this one is the step down transformer. Okay, because from 2400 to 120 volt. Okay, so keep in mind that voltage rating are in RMS. Okay, can try this example. Okay, an ideal transformer is rated at 2400 to 120. So this one is step down. Okay, step down. So you have to calculate the ratio. Okay, the ratio is less than 1, so this is step down. Okay, and then calculate the n1. So this one you can use n2 over n1 is equal to v2 over v1. Okay, this one also equal to n because you have the ratio already. Okay, so you can get n1 by arrange this formula. So n1 is equal to v1 over v2 multiply with n2. Okay, so you can try this. This is very simple. So you have to calculate the I. Okay, you can use the conservation of energy. So S is equal to VI. Okay. Or you can use the I1. Okay. Is equal to I2. Is equal to N. Okay. So, but first you have to calculate I1 first using the S. Okay. Okay. So overall for the transformer question, it will ask you like this question, this kind of question. Okay, so next is the rectifier. So rectifier you will have two rectifier, half wave and full wave. Okay, for half wave, you will use only one diode. Okay, for full wave rectifier, you will have 4 diode, or this one you can call it bridge rectifier. So this rectifier convert AC voltage to DC. Means that all the negative voltage in the AC will be positive. Okay, so it's more efficient. Okay, if you use the full rectifier. Okay, so this is a full rectifier or bridge network. Okay, so this slide and above. Okay, the next slide of the full wave rectifier will explain you how to get the full wave rectifier. Okay, so this is the rectifier. So you should know the position of the diode because the diode it have the on-off state. Okay, if you can see on-off state. So let's say this one is the positive. Okay, so this is your VRMS, right? Okay. So this is positive VI. Okay, so positive means that the supply is like this, positive, negative. Okay, so in it the current will flow, okay, from positive, okay, and will go to all the branches. Okay, here. Okay, okay, and go back to negative, and from here it will. Okay, so this diode will on. Okay, this is a positive and negative. Okay. This will this will off, this one on and off. So now your circuit just left this one. Okay, and then the which diode is off is open circuit now. Okay, which one is on is short circuit. Okay, you are not consider the 0.7 voltage drop of the diode. This is the ideal diode. Okay, so this is the flow of the current. Okay, so this is the positive, negative, and this is your VI. Now become your V naught. Okay, sorry, this one is V naught. This one is VI. VI. Okay. So V naught now is equal to VI. Okay, which is your output is positive VI. Okay. Okay. That is the positive cycle. Okay. For negative cycle, okay, I call this positive cycle. Positive cycle. Okay. So for negative cycle, okay, this one is positive cycle. You can read. Okay, this one is negative cycle. We have the second half cycle, negative cycle here. So this is minus VI. Now only the diode with reverse polarity will operate. So this one become minus, this one become positive. Okay. So the current will flow from positive to negative. And you will get the VI, V naught is also equal to VI positive. That's why you get for half cycle also positive. So output will continuously get the positive voltage. Okay. So this is the V output for your rectifier. Okay, rectifier. Okay, how about the half wave? Half wave you will have like this. Okay, so this one will slow to get the, you can get the DC voltage but slower than full wave. Okay, so I hope you can read the detail what I explained. Okay, so this is the output. Okay, the polarity of the output is the inverse of the input. That's the full wave waveform is produced. Okay, then this signal will send to the filter. So what will filter have? You will see after this. So you also will have a equation here. Okay, we have this equation VDC. How to calculate the VDC is actually the pre voltage, pre DC voltage. Okay, right. So this one is the center tap. I want you to read. Okay, so this one you will use in your lab. Okay, so this one is called center tap, but it is also a full wave rectifier. Alright, so voltage regulation is actually this one. You want to see that we don't want the voltage to drop, okay, or to increase more than its normal level. So the important here is here. Okay, this is the important formula. Percentage of voltage regulation is equal to V no load minus V full load over V full load. Okay, so the smaller the VR, the better is the operation of the voltage supply. So then we also have the voltage regulation setting for the house, okay, electrical system for house, for industry. Okay, so this one is the example. Let's say you have 60 volt of the output unloaded, so this one is no load, and when connected to load it dropped to 56. Okay, so use this formula to get the 7.1% of the voltage regulator. Okay. So before we go to the filter, you should know about the ripple factor. Ripple factor, okay. Ripple factor is the because we know that we send this signal to the filter. Okay, now we will have the filter is usually capacitor. Now we will get the like this. Okay, so in this one also we can call it as a ripple. Okay, so ripple factor is the ripple voltage in RMS over DC voltage. Okay, you want to know the ripple factor, right? Okay, can always try the example. Okay, so so you will have a half wave rectified ripple factor and also full wave. Okay, for this one is half wave ripple factor. Okay, so this one is the fixed number. Okay, so we have to memorize. Okay, so for ripple factor for the half wave is high 121%. Okay, for full wave is only 48%. Means that full wave rectified signal has less ripple. Okay, so this that I highlighted is the something that you have to remember. Okay, so type of filter circuit. So you will have a capacitor circuit filter and also the RC filter.